So hi everybody, thank you for coming. We're going to talk about teaching C++. So the title of the talk is What Makes Good C++ Programmers, a continuous search for C++ teaching recipes. And it is based on my own experience. I'm teaching C++ for many years, and I would encourage an open discussion. So feel free to ask questions during the talk. There is no need for a mic. You can just ask and I would repeat the question or the comment. It might be comments from your own experience. A few words about myself. I'm a lecturer at the Academic College of Tel-Aviv Yafo and Tel-Aviv University. I'm also a dev advocate at Incredibuild. We do build acceleration. I'm one of the co-organizers of Core C++ conference and meetup group and a member of the Israeli ISO C++ national body. The goal of the talk is to discuss difficulties in teaching C++, or we can call it challenges, and discussing teaching recipes. So it is divided into 7 chapters. The questions would be at the end of each chapter. So at the end of each chapter, we would discuss, you can add your own comments and questions. We would cover why teaching C++, the difficulties, what should we teach, a few words about class lab exercise, I mean what I do, and then we can discuss other options, homework exercise, the exam, and some conclusions at the end. Let's start with chapter 1. Why should we teach C++? I mean, there are other options, for example, Carbon. Indeed, in many institutions today, C++ is either not a mandatory course, or in some cases, maybe it is even not in the curriculum. And on the other end, many institutions do teach C++, in some cases as a mandatory course. I guess you know this one, Joel Spolsky. Joel Spolsky is known to be the co-founder of Stack Overflow, but also the guy behind the known blog, Joel and Software. And he wrote back at 2005 about the perils of JavaSchools. Those institutions who will go from C++ or C to Java. And he argued that they missed something. I mean, he says, well, back in my age, I had to, to struggle. And those lazy kids, they just, go with Java. They don't have to think about memory management. And he said as a joke inside the blog that when he raises this argument, then he recalls a joke of somebody saying that, you lazy kids, when I started, I had to write code with zeros and ones. So somebody a bit older comes in and says, you lucky bastard, I had to write code only with zeros. So anyhow, we would always find something that would be a bit more challenging in the past. And the question is whether there's value in this challenge. I mean, the argument here is that it would create a more skillful engineer if you struggled, if you, did the path of, yeah, I know about the hardware, I know more about memory management, and the question whether this has value by its own. I think an example might be teaching Latin. In many schools in the past, Latin was a language of some importance because, well, if you want to learn Italian, Spanish, French, the origins come from Latin. And at a certain point, I think empirically, it was proven that if it is not being used, there isn't any actual value. So if you want to teach French, just go and teach French and not something else, and then, have that as a base. So the question, again, for C++, if you are not going to use it, so is there any actual need or actual contribution in teaching C++? And I would say that I do agree that it is challenging and it would produce good software engineers, but for me it is not the actual answer for the question, should we teach C++? Other alternative curriculum in many institutions would start with Python, then as a system language, because you do want to see how things are connected to the actual memory. So maybe C or Rust, and then as an object-oriented programming language, Java or C#, and C++ might be a non-mandatory course. So why C++ should be a mandatory course, or at least be encouraged? Because it is being widely used in the industry. I think this is the answer. And at least this is the answer that I give to my students when I teach them. You get an opportunity to work in challenging projects, because most of C++ projects are, in many cases, more challenging, more interesting, in my view, than other projects in other languages. Not necessarily, but many of them. So we have the opportunity. And it would give you an advantage in the job market because, first, not all institutions do teach C++, and you would come with this knowledge. And it is a bit harder to complete on your own. So, yeah, I think it is important for students to come with this ability, with this knowledge. And yes, you would probably understand better how things work under the hood. But again, for me, it's the weaker argument. I mean, if I want to teach you how things work under the hood, maybe I should invest more in assembly. And in many cases, assembly is being narrowed for 2 hours, 3 hours in semester, and that's it. And again, C++ is being widely used, and this is a very good argument for, yes, we believe that you should learn that. I raised this argument to students in our first lesson, so they would have motivation for it's not just learning something which is old, it's learning something which is useful. This is the end of chapter 1, why teach C++? Because I believe it is important, because it is being used. Any questions or discussion, comments, but not about what are the challenges, because this would be the next chapter. Yes, please. Why not? Again, if you can.
Yeah, so I think my question is why you really choose to teach Java instead of.
Okay, so what is the reason that other institutions, many institutions, go away from C++ to other languages? I think that the reason is that it was considered as a legacy language at a certain point of time, might be. It might be that it is harder to bring lecturers to teach C++. It might be that it is considered harder. And there are other languages that are easier to learn. So I think that our arguments for, yeah, maybe we can teach other languages, and still, I believe C++ is important. Yes?
I have additional argument. I think C++ is the only choice we have when we talk to hardware. C has too less abstraction. Rust you cannot certify. Ada is known by too less people. 7 what is left. We only have C++. This is what I say in my classes.
So the argument here from another lecturer, another teacher, is that C++ is the only option that we have today, or the only valid or useful option for talking with our hardware, being close to the hardware. And we have C, but C doesn't have the abstractions that we have in C++. And we do see in the industry a move from C to C++. We have Rust, but Rust didn't catch the popularity of C++.
You have to certify it. This is the issue.
So there are good arguments for, yes, it is being used for hardware software that need to work directly with the hardware. I think this is a good argument. And again, it is because it is being used for that scenario. So yeah, I believe it should be taught. But there are difficulties, or let's call them challenges. There are some challenges in teaching C++, and I would start with the first answer to a student. A student comes and asks you, what is the first answer if a student asks, can I do this with that? I mean, let's take an example. Can I access an item in a vector with square brackets? So what should be your answer to such a question? The answer is simple yes. But no, yes should not be the answer. The answer should be, if you're a teacher, you get a question, and you usually would say, just try that, right? Just try it. I mean, if you try it, you learn much more than asking the teacher. The teacher would not be there for all your questions after you graduate. So you can try it. But in C++, it's the wrong answer. It's not the best answer in C++ because if you try it and it works, it doesn't mean that it is correct. I mean, this is an example of something that works. It even works if I try it with other sanitizer. We have here a vector being initialized with 1 and 2. We push back 3, so we have 3 items inside the vector, and we try to access the third element at index 3, which is not a valid position in the vector. Now, other sanitizer would not find that because the capacity was enlarged, and in some cases, it would not find it. It depends on the actual implementation. But suppose that we do have the raw memory of the capacity, then it might not be code. Anyhow, it does compile, and in some cases it would work. So trying something is not necessarily, especially in C++, a guarantee for yes, it is okay, which is a challenge. So should we say try it? I mean, there is a problem here, undefined behavior, right? And it is true for any software language that you can write something that works, but has a bug. But in C++, it is even harder problem because 7.1% of questions, the answer is, well, it is undefined behavior. Don't take this number too seriously because I just made it up. Anyhow, undefined behavior is an issue. So should or shouldn't we say just right? I do say just right. As a teacher, I believe that students should try things. But then, I would say, if it fails, analyze why. Well, if it fails, you got the answer. It didn't work. You can analyze. You can check the compilation error. You can check what happened with the debugger if it was a runtime error. If it works, you need to make sure it's not undefined behavior, but I'm not telling you that because it's a bit intimidating saying undefined behavior. So I'm just saying, well, if it works, you may assume it's okay unless it is not. Well, it doesn't, it's tautology. It's not saying much, but it is not guaranteed that it is okay. Usually, as a teacher, I do not guarantee anything unless I actually see the code. I mean, if I get a question on something, I say, yeah, it sounds reasonable, but I need to see the code. Yeah, I think that it should work, but I need to see the code. Because eventually, when somebody gets the answer and says, but you said it is okay, I didn't see the code. So without seeing the actual code, I cannot guarantee anything. Even if I see the code, I might be mistaken. But at least I see what you are trying to achieve. And if it works, or you say, but it works, again, I need to see the code. But do try it. Because when trying things, you learn much more than just asking. We're still in chapter 2, the challenges. New ways of doing things. Old correct answers become obsolete or just wrong. For example, even in CppNorth, you get occasionally good answers for questions in the talks, like it depends. Well, I'm not sure. I don't know. So what can we do as teachers? I mean, the ground moves. We have a new version of the standard. Things that worked before now work differently. For example, this code fails in C++14. This is an example of something, well, it would fail because the copy constructor was deleted, but in C++17, since we have mandatory copy elision, then you actually call the first constructor directly. I mean, it is a mandatory optimization. Well, before it was an optimization, but not mandatory, in which case C++14 gave a compilation error on that. So things change. Move on return. If I return something, so we have implicit move on return, right? But the rules on implicit move on return changed over the standard versions, over the specification versions. So there is a very good talk by Arthur Dwyer in C++ Now 2021, if you want to listen to that, on the change of the implicit move on return rules. So what should you do as a teacher? Maybe you even do not follow all the changes. What about aggregate type? The rules of aggregate type changed since C++ 11 4 times. I mean, they removed something, they added something. Are you an aggregate type? Well, it depends. What should you do with all this information? So things change, but don't get into each and every bit. Keep things simple. I mean, go away from these complications. You don't have, as a teacher, to touch all these things. Touch the simple things. And remember the teaching and cheating? Share the exact same letters. I would say for a reason. Teaching is a bit of a cheating occasionally. I mean, you do not tell all the truth. You just say, okay, you are doing it fine. Yeah, there is another way to do that, maybe better, but it's okay. Or you present something, it's not the best way, maybe there is another way, or maybe something is good for this version, in another version it works otherwise. So yes, it is okay not telling all the truth. I mean, if you want to tell all the truth, a single lesson might go too deep into the details, which in many cases is not the actual goal. You don't have to be exact in each and every answer or explanation. It might be that you are not up to date with the specific details, and that's fine, as long as you are on C++ 11, 14, 17, and not on C++ 28. So it is okay if you say as a disclaimer, for any practical aspect, this should be the answer. Or there is something more to it, but we will not dive to it. I mean, yeah, that's the answer. Maybe there is something else, but I would not dive into it. On the other hand, don't stay behind. If you're teaching C++ 98, you're not doing good for your students. We're still on the challenges. The rules are difficult. Students, and most of us actually, learn much better for examples. So if we have a good example, it's much easier to learn from an example rather than, I don't know, reading the spec, reading CPP reference. So for myself, for every rule and methodology that I teach, I have at least one code example showing that. And the attention in class is on the example. I try to personalize things. So for example, if I present this one, I tell that, well, the compiler is tempted to give us compilation error because I send a char star, a const char star to a function that expects string. But then the compiler recalls from his compilation school, he had 3 years at compiler school, and he recalls that if you can cast the sent argument to the expected parameter, then you can do that. And yeah, I can create a string out of the char star. And this is because it is a const reference and not just an L value reference, but I personalize things. I try to look at the compiler as one of the players there. And usually it adds some vividness into the lesson. A few more challenges. The logic behind C++ rules may be arbitrary. For example, in C++ 98, we didn't have direct member initialization, and some of the books had good explanations for that. Like, for example, you do not have the memory. You cannot assign to the member because the member is not alive yet. It is not born. Well, I would say that this is a bad argument because the compiler can create code out of that, saying that when the member would be alive, would be born, I would initialize that with a value. And that argument indeed was invalid when in C++ 11 you could initialize the member. So in some cases, the argument that you would give either would be broken later on, or it is just, a bad argument. So in many cases, my argument for why does it work like that is because the spec says so. And in many cases, it's a good answer for cutting too long discussions. So if there is a long discussion of, but it doesn't make sense, well, maybe, but this is what the spec says, and that's it. And the students understand that eventually there is specification, and the language should obey to the specification. Other challenges, too many questions in class. Well, there are many details, and many details generates many questions that actually divert you from the planned material. So what I do is I divide the questions in class between understanding and extrapolation. So anybody who has a question on the code that I present must quote the code, the line number. So, oh, I have a question on line number 12. I have a question on line number 16. And if the question doesn't start with the line number, oh, maybe it is an extrapolation question of what would happen if. And then I postpone these kind of questions only for after the entire class understood. And in some cases, the student who wanted to ask just forget the question, and that's fine as well. He can write down and ask, but in some cases they just, and in some cases it was answered by some specific other questions. So I prefer more specific questions than something which is quite vague. And in many cases I just say, oh, that's a good question, let's discuss that in the break. And in the break they go. In some cases they come and ask, and that's fine, but in some cases they just prefer to take coffee. Summarizing. There are challenges. It's a complicated language with many details. Be careful with too many details. Spare it. Cheat a bit. Stick to good code examples. Make everyone aligned before getting to extrapolation questions. Use modern C++. Don't stay behind. And keep updating your materials. Any question or discussion on chapter 2, the challenges? Any challenges that you see that I didn't list? Yeah, please.
What about error messages? Because I've noticed a lot of times the significant length of error messages.
What about error messages, compilation errors? So I will discuss that in a later chapter. That's a very good comment. The error messages are quite scary sometimes. And you know, in many cases, I see students get something that does not compile, and then what would they do? In some cases, go and fix it. Yeah, before reading the actual error message. I mean, the compiler said what the error. You just go. I do that the same occasionally. I just presume that I know what is the problem, and then I try to fix it, and then I say, no, the compiler said something else. So they are not alone. This is how we think. We just guess what is error, and we go for fixing that. So in a way, I'm trying to educate them, and I would touch that later on when and how I do that. Because it's quite natural for us. Oh, I think that I know what is the problem. No, the compiler said you have to read that, which is quite an effort to try to understand what the compiler actually wanted from me. Yes, please.
I have it sometimes in my classes, but I don't give. I teach universities. I teach in companies that you have a few extremely smart people in your audience, and one wants to prove to the other that he is smart and he has extremely smart questions. Sometimes I have to go to them and say, I will not answer your questions here, do it in the break, because all the other teams, 80%, are totally frustrated because they even don't understand the question.
So the comment here was that in the industry, but I think that it goes also in classes at colleges and universities, you have those smart students that ask good questions, or sometimes not such a good questions, but on some advanced materials. Or, oh, can I do that with smart pointers? Well, we didn't reach smart pointers yet. So I usually postpone the question. I mean, I would not touch a question which is too advanced, because otherwise I lose the class. So I prefer to postpone that. In some cases, I do find a reason to discuss shortly a question, even though if it is beyond the current material, just because I think it deserves that. I mean, maybe it deserves a quick answer, but if I feel that it would divert the line that I have, and you know, I would lose the attention of the class, I would just postpone it. Chapter 3, what should we teach? So, this is something that is being discussed in SG20, the committee under the ISO C++ discussing the C++ education. And there isn't any answer for that. But there is some kind of curriculum that you can choose from. So I would not tell you what you should teach, but I would tell you what I teach, okay? And then we can discuss whether it is a good choice, I pick the proper things or not. So I teach 2 courses. One of them is a mandatory course for second year undergraduates, and the other one is a non-mandatory course for third year. And these are in 2 different institutions. The first one is at the Academic College of Tel-Aviv Yafo. Second year student, this is a mandatory course. This is the first object-oriented course, and they know C before. So we do the basics of our syntax or object-oriented understanding and practice. Our value and move semantics is an optional bonus. I found out that our value and move semantics are quite tricky for students, and I tried at a certain semester to make it as an optional material with a bonus at the exam, and it worked very good. I mean, they succeeded in the exam on that part, I would say even more than when it was part of the actual material, part of the mandatory material. And I think that because they realized that, okay, I can go over it, we discussed that shortly in class, but we didn't dive into it and you know, went through many examples. They did it on their own. Templates, Lambda expressions, and of course, containers and algorithms. So eventually they are able to write sophisticated C++ code and to read, which is also very important, to read C++ code. On the other course at Tel Aviv University, this is a third year undergraduate, non-compulsory, and they have object-oriented course before, Java, and they have C, and we cover more. We cover also concurrency and multi-threading, which it was not in the other one. We cover smart pointers, which again was not in the last one. The previous one, we do not read smart pointers, even though I do touch smart pointers. I do talk about that. I do present a class of our own that implements something that seems like a smart pointer with a reference counter, and I tell them, oh, there is something very similar in the language, but we do not cover that at class. And in the other one, we do cover smart pointers and concurrency and multi-threading. The goal is that students would be able to implement complicated projects in C++, like, for example, these are actual projects that they get, autonomous vacuum cleaner that needs to learn the structure of the room or the house, and do BFS or DFS, and actually clean the house, go back to its docking station, ship storage management, like putting the containers on the ship in a optimized way, and games. I like giving games like Tetris, Pac-Man, and I would show you the Thunderbird. And read complicated C++ code. And I would discuss that when I would talk about the exam, because in the exam, I ask them to read code. And reading, I would say, is in many cases, we do not invest enough in educating our students to read code, and reading is as important as writing, because 80% of the time they would read code, and I do put some emphasis on that in the exam, on the chapter on the exam, I would discuss that. There is, of course, the very known talk by Kate Gregory, Stop Teaching C When You Teach C++. So where I stand about with that, they already started with C in both courses that they teach. So they know C. They come with C knowledge. And yet, in some cases, I go top to bottom. And top to bottom is, okay, I, for example, teach them working with containers before they know templates. And then we teach templates. On the other hand, in some cases, I go bottom up. I prefer to implement our own string class before seeing std string, because in a way I want them to understand how string is being built. So yeah, I'm teaching them C in a way. I mean the C part of C++. Yeah, we do pointers, we do row pointers, we do allocations. But at the end, I do talk about rule of zero and why you should prefer managing your pointers in a specific class, or maybe even using smart pointers. So yeah, it is C with C++. I'm not giving away the pointers part. This is the end of chapter 3. What should we teach? I mean, what I teach, but I would be happy to hear about what do you think the industry needs. Maybe I miss something that I should teach. Maybe I teach something that I should not. What is your stand on that? Please.
Value semantics is missing.
So value semantics and the understanding of reference versus values versus pointers.
Well, yeah. How to write a type that has value semantics.
Okay, so Dave here says that the notion of value semantics. So we do talk about values, we do talk about references, but the idea of, yeah, your type is as value semantics or not, yeah, I think it is a bit more maybe advanced topic. I don't know, but we can discuss that. I understand the point, and it is a good point, something that we can discuss.
It's kind of ends up being a basic requirement for using any of the standard components. Like you want an algorithm to sort. For that sort to be meaningful,
Mm-hmm.
things need to have value semantics.
Yeah, so the comment here is that for many algorithms and operations, you need to understand value semantics. Thanks.
Well, you need to have it. Whether you understand it or not is a different thing.
Yeah, you need to define that. Thanks. Yes, please.
Well, in the same branch of value semantics, do you teach the rule of 0, 3, and 5?
Yes, it is there. Yeah, I do teach the rule of, the question was, do I teach rule of 3, rule of 5, rule of 0? And the answer is yes, I do teach rule of 3. And then it is in one course as the optional material as part of our value and move semantics. And in the other course, it is mandatory, the rule of 5 and rule of 0. Yes. Yes, please.
I would probably spend some time teaching students how to navigate style guides.
Okay, how to navigate style guides. I mean, if I understand correctly, to read style guides, to understand what are the recommendations.
Right.
Yeah.
I think this is a problem of C++ because there is no one. Like Go has one or Python has one, more or less.
So the comment here is that other languages have a more sustained one style guide, and in C++ we have many, and you have to. So in a way, I think that I try to do that by coding with them. So they get my conventions and my style guide in a way, but yeah, it is something that we may take. We do publish something when we require them to submit their exercises. So they have some kind of a style guide that we publish as, okay, we want your exercise to follow these guidelines. So maybe it is
But
something like that.
You know, as a C++ developer, you must know that if you're contributing to LLVM, it's going to look this way, and if you're contributing to something else, it's going to look a different
Yeah,
way.
the comment here is that in C++ you should know that there is no single style guide or convention, and it means that it might be that you are now educated for some specific one, and you would meet another one down the road, and yeah, that's correct. I would go for chapter 4, which is on the class lab exercise. So we have during the course both lectures and lab exercise. And in the lab exercise, in some cases they write their own code. I mean, they get a task. In some cases it is on their homework. In some cases it is a task that they get during the lab. And in some occasions, the one who is writing, the one who is implementing the task is the teacher, which is either me or a teaching assistant. And live coding with the students is something that I like. I mean, there is something with live coding. You handle actual compilation errors and runtime bugs, which relates to the comment that we had before. I mean, the teacher also has bugs and compilation errors, and some of them are not intentionally. I mean, yeah, it is an actual bug. I didn't plan that, and then I have to think with them how to find the bug, locate that, understand, and they see the methodology of how I approach the bug. They see how I try to read the compilation error, or in some cases, how I forget to read the compilation error and run to fix something without reading, and then they say, yeah, but we need first to read the compilation error before we rush to fix that. So in a way, by doing live coding, they see that first others, not only students, have bugs, and they see how to approach that. And even in some cases, how to go and figure out things on the web. I mean, how to go to Stack Overflow or to reach, or to go to CPP reference and say, oh, I know, I used the wrong argument. We need to switch between the two arguments, for example. So live coding is something that they learn pretty much from. And actually reading the compilation error message is something that I do with them, going to the web and debugging. And again, it is in many cases not planned ahead. I mean, the bug just appeared. I didn't plan that. For example, I will not go through the code because I don't have the time in this session, but there is an example with a very embarrassing bug, the first one, that I actually did in class, and then something just crashed. And then we debugged it, and I fixed it, and then I said, you know what? If I would use smart pointer, this bug wouldn't appear. Now, we didn't talk about smart pointers in class, but this was an opportunity for me to say, I know why I did this bug because I was not using smart pointers. And then I did the same thing with smart pointers, which was an opportunity. I mean, I said it is not for the exam, don't worry. It's just, I just want to do the same thing now with smart pointers, and I fixed the bug in two ways. First, with regular pointers, and then again with smart pointers. A comment, please, or a question.
A couple of things. So when I was doing a lot of teaching, one of the things when I had to help people understand error messages, there's a tool that I would always recommend that they use that actually can help a lot. It's called STL filter. It's a very old thing written in Perl, but it takes a lot of the noise out of error messages and makes it a lot more approachable. So that can be really helpful. In fact, like if you have a long template, it will format it with indentation so you can see the levels of nesting.
So I would repeat the comment here. STL Filt is a tool that assists you in comprehension of error messages, compilation errors. Like for example, if you have a very long template error message, so it put it in proper indentation or something that is more readable. So
remove the STDs.
Removes STD from all the types, etc. So STL Filt. This is something that can assist them, can assist any programmer, not only students. Thank you.
So that was the first thing. And the second thing, since you mentioning pointers, for a lot of us who have thought about programming at scale, one of the things that we see is overuse of smart pointers or overuse of pointers is actually causes a lot of problems in software. And so I think when I said value semantics, another way to look at that is we should be teaching people how to avoid using pointers, right? Rather than, I can fix it by using a smart pointer. Think about whether there's a way that doesn't expose any pointers at all.
Mm-hmm. So I think that, again, the comment here is that in many cases, the problem to begin with was that you were using pointers where maybe you could use value semantics. And in this case, there was some polymorphism there that required some pointers. I understand that it might be that you can do things otherwise, but in many cases you do that with pointers and with allocations, and this was the case there. And again, we can discuss later the exact example, But you do see actual code that do use pointers and allocations, even though, yeah, you can go with value semantics for many things. You can wrap things with value semantics and do things maybe inside otherwise or without allocations at all. So this is the comment or the idea.
Well, you can express anything with value semantics. You can express an arbitrary graph as a vector of vectors of integers. And so all your relationships, whatever graph you have. Now, there are some things that may be less convenient to express without pointers, but the problems that come when you try to scale that code up are very serious. And so I think we very quickly fall into the trap of, oh, but pointers are necessary for this problem.
Yeah.
But they are never actually necessary. The
So-
question is, how good a fit are they?
So the discussion here, do we have a recording? I return, right? Do we have a recording over there? Just want to make sure. Yeah, otherwise I just repeat the questions without a need. I repeat the comment that in many cases, value semantics can be a proper replacement. And again, this is something that we can discuss. But in any case, bugs do appear, even if you go with value semantics. And the idea was that in live coding in class, you can show the students how you overcome bugs or how you read compilation errors, and this is something that I do with them. So this was the chapter on the lab exercise. I would go further to the homework exercise. So this is an example of last semester homework exercise. It is based on a game that I was playing when I was a kid called Thunderbird. Maybe some of you know that. There are two spaceships inside a pyramid in Egypt. This is the story about the game. And they should move objects in order to move in the tunnels. And the big one can move big objects, and the small one can move small objects, but it can go through narrower tunnels. And this is not what they created, even though they can create things with console application like that. It is console application at the end. They created their own version of Thunderbird with the rules that I provided. And eventually it is quite a complicated game. And they get comments on their code. I mean, comments are very important. If you submit an exercise and nobody reads that, I mean, somebody needs to run your exercise, to play with that, to see if there are bugs. Otherwise, you know, it doesn't worth anything. And somebody needs to read your code. So we read the code, we run your exercise, and you get code review comments, and you get run comments. And for most comments, we reduce points. I mean, even if we want to reduce half a point, we reduce half a point, and there half a point there for each comment. In some cases, it is 5 points. But they see the reductions because if you do not reduce points, they just ignore the comment. There is a comment here.
I just want to be real quick. This is from somebody in industry, and I understand what you're doing, and I think it's a great idea. But one of the problems we have when we get into industry is a lot of people see code review as a competitive process or a argumentative process, where really it should be a cooperative process. And this sort of teaches the idea of code review as I don't want to get any comments on my code, but comments are actually good things to improve the code. But sorry, I just didn't.
Yeah, so the comment here is very important, is that code reviews should be cooperative and not competitive. So in a way, they should learn that things can be done otherwise and not see things as too much of judgment, if I take the comment. And indeed, we try to point them at guidelines, at bugs, at things, and we do that in quite gentle way. I mean, at the end, they get grades, so it might be gentle, but minus 10 points. But yeah, you have the crash, for example. So yeah, they get comments, and we try to be gentle and to be cooperative. They have to learn from that. And again, we subtract points.
Do they ever surprise you with really good code?
Yes, they do.
Great comments?
Yes, they do, and they get comments on that. Yes,
Okay.
in many
You take
cases,
points off for that too.
and they get bonuses for that. So they get bonuses on features, on good design. And in some cases, yeah, you get something and you say, whoa, that's smart. How could he do that? How she could do that in such short time for submission? Yeah. I mean, this is what makes me happy, to see good, and to see bad exercises as well, and to teach them how to, do better. An important note that I emphasize, a working, though imperfect, exercise is better than a perfect, great code, non-working exercise, because eventually they need to be software engineers. They need to come to the industry and deliver. And if they work on improving the style, improving the design till the last moment, and not on testing, and not on making sure that they meet the requirements, then, the exercise fails. So working is more important than, oh, it's great code. Yeah, you may lose some points on, I think that the function is too long. Maybe you could write the class otherwise, but it works, which is very important. This was about the homework exercise. If you have any question about that or comment. Yes.
So you actually have time to rate your students'
So the question was, do I have time to rate the students' work?
In my university, it's OTA, doesn't work.
Yeah, so I have a teaching assistant who actually, or a checker, who actually checks the exercises, and I review that. So I'm not reading all the code, I'm not running the code. I have teaching assistants for that, but then I review what they did. And in many cases, after the review, if they are new, I talk with them and we do it again. Usually, if it is a new teaching assistant, I tell him, okay, do 10 exercises, and then let's discuss that before you go for the rest. But I don't have the time to go myself over that, but I do take a few. So I can take the comments and read the exercise and see if it fits. Which usually I can tell that it works well when students come to discuss with me the comments that they got from the teaching assistant. And in many cases, I know what is the comment because I read it. Yes?
Do you have a forum for your exercises?
Do I have a forum for the exercises? And the answer is yes. They're asking the forum questions about requirements, about design considerations. So usually I get emails only for personal things. I mean, if you need something personal, write me an email. If you need a question about the exercise, there is a forum. I want the question to be public. I want my answer to contribute to the entire class. And yeah, I want you to be able to ask a question on the requirements in a forum. So yeah, they do that. The exam. In the past, I had two parts of the exam, writing code and reading code. It was 3.5 hours, which is quite long. And they got a question for writing code, for example, implementing the backend of a Monopoly game, or implementing a backend of 9-on-9 spreadsheet engine. It's quite complicated, but this was what I expected. And in the reading code part, they got about 100 lines of code and questions about this code. In the lightning talk today, I would give an example of a reading code exam. So I would not give it now, but think that, okay, this is the code, and now some questions. And in many cases, students ask me, but what is the point of asking us to read code when, it's the exam, we cannot compile it, we cannot run it. If we were in our own environment, in order to understand the code, we would compile and run it and debug it, and then we would better understand. And usually my answer is that, well, you have to gain the skill of reading code and understanding the code, even, it is 100 lines, about 100 lines or less than that, by only reading that. I mean, yeah, usually you will be able to run it as well, but not always. In some cases, you have to understand it without running. Maybe you do not have the environment, you don't have the time to run anything. So this is a skill that you need to acquire. And usually I think that when something in the exam expects you to acquire a skill, it directs you to, yeah, I need to know that. I need to practice that. Some important notes. I give them some examples before. So usually on the reading part, they come to the exam and they see something which is familiar. They say, oh, we saw that code, but then it is not perfectly the same. It is not exactly the same, and they do not get the question said. Now, I earn here two things. First, I reduce dramatically their anxiety part. I mean, hey, we saw that code. And they succeed. I mean, yeah, they get something that otherwise would be quite hard. And the other thing is that preparing for the exam and reading the examples that I provide is part of the learning. So I provide code and I say, okay, you would get some of these in the exam, and they go and learn that. And they go and understand, like for example, my implementation of a smart pointer, my implementation of a vector of Booleans, or things like that. And in the code that I give in the exam, in some cases, there is an intentional bug. I mean, the code doesn't have to work. In some cases, there is some line that does not compile. And in a certain question, I put it in a comment or get it out of a comment, and they should be able to understand whether it compiles or it doesn't. Maybe even if it is a compilation error or a linker error. In the past, I got 40% failures, and the average was 70 out of 100. A big line of students in front of the dean office, and many complaints. And it took me time to understand that the complaints are right. They were right. At the beginning, I thought that, yeah, this is what you are expected in the industry. And, you know, if there is a need, come to the second term and do better. But then I realized that even good students, in some cases, it is quite hard to write code under pressure. Now, when I argue that, some people say, but this is what they would be expected in interview. And no, interview is communication. Interview is speaking with somebody about your code, which is not in the exam. So after trying, for example, to separate the two parts, giving, I thought maybe they do not do good on the writing part because they do not manage the time correctly. So I separated it into two parts. It didn't help. I lowered the demands. I gave them the opportunity to write in a text editor. Why not in a compiler? Because then they waste the time on making it compile, which is not what I want. I want just to see the design, the overview of what are you aiming to do. Nothing actually helped. I mean, I got good exams. Some of the exams were brilliant, but not all of them. And those which were not so good, in many cases, I felt that it is a good student. So eventually, I have only a reading part in the exam. So I let them write code in the exercise. There is quite a problem here, because how can you tell that the person actually wrote the code? Maybe it was his friend. I don't know. I trust them. But then in the exam, I just today do the reading part. And now we are on 10% failures. The grade is better. The students are happy. The dean is happy. And I feel that it is fine. It's not compromised. I think at least this is what I convinced myself. So I do have a bonus part in the exam, which also assists in getting the higher score, which is on the non-mandatory material, R-value, and move semantics, and other parts that I skip or tell them that they can learn on themselves. This was the end of chapter 6. I think that I have time for a comment, one comment maybe, or a question on the exam. Yes?
I think in the industry, we've more broadly started to realize that live coding exams don't really work. There are enough people that really need the time to go off and think about it that you can't do that. And a lot of times we've worked out
So the comment here is that in the industry as well, we realize today, many people realize that live coding in an interview is quite demanding and not necessarily reveals the quality of the person that you are interviewing. And in some cases, homework assignment for interview, and then coming back and interviewing and trying to see if the person got it right is better. I agree. I totally agree. And I think this is the direction that I'm taking here. We are coming to the conclusions, which is the last chapter, which is some kind of a summary. So, most important part when we're teaching, build their motivation. It's very important. Let them succeed. Create sense of ability. Let them enjoy the beauty of C++. This is very important. Yeah, there is beauty in C++. Remember, they are just students. Adapt your expectations. On the other hand, don't aim too low. Let them work hard, but help them. The C++ syntax is a tool, but you want also to establish good software engineering practices. Try to hold both. I mean, it is very important that at the end, they would invest in testing, understand that it compiles is not enough. So good engineering practices start with, it should work. You should read the requirements. You should understand the requirements. You should ask questions. Any questions before we conclude? So the question or comment was that, is it individual or is it team? So they submit their exercises in teams of two. Okay. They work in pairs on the exercise. I actually enforce that. I mean, they must work in pairs, otherwise they get a fine. So I allow only a single person to submit alone, if the number is odd. Otherwise, everybody must submit in pairs, and I do hope that they work together well, but they need to work out how to do that. We do publish some recommendations on how to work together. So we try to, in a way, educate them on how to work in a team.